G'day all and welcome to another tute. So today we're going to look at overloading functions. We can actually have more than one function with exactly the same name in C++, so long as they have different parameter types. And it's called overloading a function. So the two functions need different parameter types, not just different names for their parameters. We'll have a look at the end at an example of this, but the other thing to be careful of is that having a different return value isn't good enough. The actual parameters have to be different. Okay, so here's just a few little examples. Just have a bit of a look at each pair of these and have a bit of a think about whether or not this is legal function overloading or not, based on the rules from the previous slide. So the first one, void SomeFunction and no parameters, and void SomeFunction and int a. Yep, no worries, that's fine. They've got different parameter types. One of them doesn't take any parameters, but the other one takes an integer. So C++ can figure out which one we mean, and that's perfectly legal. The second one, no good. This is wrong because even though the parameters have different names, in the top function they're called a and b, and in the lower function it's called g and h, the functions both have exactly the same types. Yeah, they both take two integers, so that's not legal overloading. C++ won't let you do that. And the third one down here, int SomeFunction int a and float SomeFunction int a, is that legal? No. That's not legal. The only difference there is between the return types, int and float, and that's not good enough. The parameters have to be different, otherwise it's not legal. Finally, down here we've got float SomeFunction and a bunch of integers, and int SomeFunction and a bunch of floats. And the float parameters are called a, b, and c, and the ints are called a, b, and c. Is that legal? Yes, that's perfectly fine. So the parameter types are different, even though they've got the same names, and the return value is different, but that's got nothing to do with it. The parameter types are different, so that's perfectly legal overloading. Okay, so I wanted to come over here to C++ and do some little examples on exactly that. What we might do is make a couple of functions. So I might just say void SomeFunction, and we'll say int a. Just like that. Just a perfectly normal function, takes one integer a, and then it prints out whatever the value of the integer is. Now if we do something like in our main method, int maybe myInt equals 23, obviously we can do SomeFunction myInt like that, and C++ is going to call this function. It's going to print out that myInt equals 23. But the other interesting thing that you can do, we could do something like float myFloat equals 3.7f. Just like that. So there's not actually a version of SomeFunction that takes a floating point value, but C++ is clever enough. If I type in here my float, my gfloat, my gloat, it's even worse. If I type in here my float, C++ is going to have a look and it's going to see that there's actually only one thing called SomeFunction, and it takes an integer, so it's going to go, well, you probably meant this one here, and it's actually going to transform my float into an integer and call this method just here. So let's just have a play, because it does something interesting. There it is, integer is 3. Okay, so that's this float just here being passed. Now you might notice that 3.7 converted to an integer becomes 3. It doesn't become 4. It doesn't round it up. All it does is cuts off the decimal places. So my float actually becomes an integer, and it turns out to be 3. Anyway, that's not function overloading. That's called casting. But we're not doing that at the moment. What we want to do is void SomeFunction float f. Float is and f, end all. Now we've overloaded a function. So we've got a function with exactly the same name. The only difference between the two is the parameters. One of them is an int and one of them is a float. So this one down here, SomeFunction, and I take a float as the parameter, is actually going to call this one. Because it sees that it's a floating point value that I'm passing, it knows that we don't mean this top function, we mean the one with float. So let's have a look. There we go, 3.7. Good stuff. So it didn't call the integer one and cast it and chop off the decimal places like it did before. Now it's got one that takes a float parameter. Also we can do like that, SomeFunction myInt, and that's obviously going to call this top one here since we're passing an integer value. So this is how C++ determines which version of the function to call. It determines it with the parameter that we pass, which is why if a function has exactly the same parameter list, it doesn't know which one we mean. So yeah, it's not legal overloading. Anyway, if we play this, we should get 23 and 3.7. Yeah, there we go. So the integer is 23, the float is 3.7. Now, what's interesting, this is interesting, what if we do something like, instead of passing an integer, what if we pass a double? My dub. And I copy and paste that there. So what's going to happen here? We've got SomeFunction and we're passing a double. So C++ has it's got to choose either this one with the int or this one with the float. But we're not passing an integer or a float, we're passing a double. So it doesn't know what we mean. It doesn't know which function to call. If I hit play, it's going to give us an ambiguous function call. Here it is down here, SomeFunction, ambiguous call to overloaded function, which is another way of saying I have no idea which version of the function you want me to run. Yeah, it can't tell. But if we cast this to a float, for example, just like that, by putting float in brackets, it's happy to convert this double into a float and call this version, SomeFunction with a float. Or we could do this and cast it to an integer, then it will be happy to call this version, the top version, with an integer. Or what we could do also is void and SomeFunction double D, like that, and write another separate function to deal with doubles. Yeah, just like that. And now it's going to know which one to call. It's going to call the double one, this one. I think actually it doesn't equal anything, so I better set it to something, maybe 2.3. Yeah, there it is. So it calls the double one. So the important things to know about function overloading is that you can have as many different functions as you want, so long as every single one of them has different parameter types. And you can have more than one parameter in there if you like. And if C++ can't tell which version of the function you mean, like when we passed the double a minute ago, it's going to complain and it's going to tell you that it's ambiguous and it can't figure it out. You can do some really tricky things, so we could do something just like this. This would be really weird, but maybe int mydub. Okay, so what's that going to call? That's obviously going to call the integer version up here. If we hit play, yeah, there it is, 2. So once again, to convert the double 2.3 to an integer, it doesn't round it, it just chops off the 0.3 just there. Yeah, it's called truncation. Converting floating point or doubles to integers almost always means truncation, chopping off the points. It doesn't round it. But we can get extra tricky and do this if we like. What does that mean? What is it even going to call? What is going to happen? Well, I'll tell you what's going to happen. It's going to be pretty cool. It's going to call this integer one just here, but it's going to print out a really weird number. Let's have a look. Oh, yeah. There we go. Yeah, why did it do that? Well, I'll leave that as a puzzle for you to figure out. Well, we could do this too. This would be cool. 2.7 by 10 to the power of 23. Yeah, don't worry about those last two examples. That's just playing around. But yeah, function overloading is really, really useful. And have a bit of a practice, have a bit of a play. Thanks for listening. See ya.